On a planet far, far away lived the people of Krebula. Hundreds of years ago, a mass pandemic swept through Krebula and wiped out a sixth of the people on the planet. The pandemic caused Krebinians at any age to exhibit sudden symptoms, usually relating to the nervous system. For years, no one knew what was killing the people of Krebula until a biochemist by the name of Dr. Grover recognized the symptoms, such as muscle weakness and brain dysfunction, which she linked to mutations in the Krebs cycle because of the nervous system's high requirement for energy. Since then, research and technology has relieved the impacts of these mysterious mutations. Scientists of Krebula have discovered that patients have 1 hour after symptoms present themselves to seek treatment and survive. The date is May 20th, 2075, and it is a holiday called Restula on Krebula. Nobody can work today as it is a day of rest and time to spend with family. Hey Dan and Jorley, two 20-something best friends who just graduated from Cal Polypeptide, were tanning in the backyard of their house near campus, activating tyrosinase and creating some much-needed melanin. They were casually reminiscing on memories made during their time at Cal Polypeptide and how they took Biochemistry 1 as their last course of college. After all, only the most committed students survived the rigors of CH 382.
Wow, it sure is nice out here. Although I may have had way too much coffee this morning and became dehydrated because I'm not feeling well and my head hurts.
Oh no, that's weird. I just started experiencing this annoying eye twitch. Hopefully, we feel better.
Oof. I'm a little worried. Hey Dan, my headache has gotten significantly worse. Oh, and I tried to pick up my water bottle, but I couldn't grip it.
Oh man, here, let me grab that for you. Oh no, Dorley, my hands. Now that I'm remembering, my mom had her mutation in her Krebs cycle at around the same age.
Now that you mention it, my great uncle died of his mutation around 21 when he had a mutation in his succinyl CoA synthetase that went untreated for more than an hour.
How long do we have?
Well, if my calculations are correct, only 54 minutes before.
We need to get help, but it's Restula on Krebula today, so no doctors are working. Do you remember where Dr. Grover lives? She's our only hope.
You know what? I remember seeing her playing with her kids in her yard. It's close by. Let's go.
Dr. Grover, can you help us? We've experienced our mutations in our Krebs cycle. We need your help. We only have 45 minutes before.
Sorry, girls. I'm with my kids. I taught you well. Figure this out on your own. Here are the keys to my lab. Come back to say hi if you survive.
Whoa, Jorley, my eyes. I can't control it anymore.
Uh-oh, these symptoms are coming in faster than I thought. We have to figure out what part of our Krebs cycle is mutated. I remember reading a study where they did a urine test to test levels of enzymes. Got the results. Uh-oh, it looks like I have really high levels of malate, but I can't remember what part of the Krebs cycle that's in.
I remember. It's in the beginning.
Malate is a step in regeneration of oxaloacetate. It's converted to oxaloacetate by malate dehydrogenase, which might be mutated in your case.
You're right. I read about a case where a young boy experienced his mutation and doctors found that he had developed a mutation in the gene that encodes malate dehydrogenase, MDH2. He had acquired a mutation that caused two amino acid substitutions, proline 133 and proline 207, had been spontaneously changed into leucine. He also experienced muscle fatigue and brain dysfunction. Since that case, this specific mutation has been well studied as it is very common due to malate dehydrogenase's vital role in the catalyzation of malate oxidation to oxaloacetate, paired with reduction of NAD+. They discovered that proline 133 is in the turn between the alpha helix and the beta strand, and proline 207 is located on the beta strand of the dimeric enzyme.
Ah, I have the chapter of the textbook right here.
Perfect.
Those mutations may cause improper folding, which could lead to protein aggregation. Plus, conversion of malate to oxaloacetate is crucial not only for Krebs, but also for the malate aspartate shuttle and gluconeogenesis. Luckily, asparagine is also a precursor for oxaloacetate, so you'll be okay for the time being. On another note, from the urine test, I see that I have high levels of citrate. I'm blanking. Quick, do you remember anything about citrate?
Well, I do remember that the names of the enzymes in the Krebs cycle are named after the reactions that they catalyze. And early on in the cycle, citrate is converted into isocitrate, in which the hydroxyl group moves carbons via a hydration followed by a dehydration to form an alpha keto acid needed for reactions later in the cycle. Wasn't there an intermediate step in there?
Ah, but of course, the stable cis aconitate intermediate. I need aconitase. You've jogged my memory. There was a study about people who had mutations in ACO2 coding for the iron sulfur cluster in aconitase. They experienced similar symptoms like eye abnormalities and muscle twitches, and others such as seizures and brain atrophy due to the buildup of citrate that was unable to be converted to isocitrate. Aconitase was no longer able to perform the dehydration reaction due to the mutated iron-sulfur clusters, which meant a fourth iron could not bind to the 3 irons present on the enzyme to interact with the hydroxyl oxygen atom in citrate. The stable cis-aconitate intermediate could not be flipped 180 degrees along the alpha-beta carbon double bond to form isocitrate. While this reaction has a small delta G, Le Chatelier's principle favors formation of the lower concentrated products, so isocitrate is able to be formed.
Good memory. We need to now somehow supplement me with malate dehydrogenase and you with aconitase. Do you remember how we had to write that protein paper for BioChem? Well, I remember seeing some papers when I was researching my protein that was talking about synthesizing these enzymes from different plants, like a watermelon and a tomato.
My favorite fruits! And the Krebs cycle is used by all aerobic organisms, so we should be able to use their enzymes. Maybe we could check the staff kitchen for some?
We'd better hurry though. Looks like we only have less than a half an hour before.
Now let's put on our personal protective equipment.
Okay, we need to figure out how to supplement ourselves with malate dehydrogenase and aconitase, knowing the biochemistry, for the time being until we can make it to the doctor after Restula on Krebula. It is a good thing that we designed a protein purification protocol in class. We just need to extract the cDNA of interest from our fruits so that we can use PCR to amplify it, then ligate it into our vector into bacteria. From then we can purify malate dehydrogenase and aconitase out and inject it into our bodies.
True, we don't want to ingest peptides as that would break down in our stomach. It sounds like the best option we have for now, but we better hurry. Time to do some
Biochemistry.
I guess this is the moment of truth. If I don't make it, tell Dr. Grover that I love her.
Hopefully our biochem knowledge was accurate. Aconitase, here we go. Hayden and Jorley bought themselves just enough time to make it to the doctor the next day. They were able to catch up with Dr. Grover about their adventures and thank her for saving their lives and saving them money by creating their own temporary treatments. They were forever grateful to have taken biochemistry as their last block at Cal Polypeptide and went on to live their lives at the fullest extent, having experienced their Krebs cycle mutation on Restula and survived.